Okay, hello everybody. This is a short video on using serological tests to measure post-vaccination immunity to foot-and-mouth disease. All the things that I'm going to talk about during the video will have been covered, I hope, in more detail in the course materials that you are doing. But I think it's useful to have this as a sort of complementary overview of some of the things. So let's see how it goes. So the aims of this video is to help you to understand the uses and limitations of serology as a measure of immunity to foot and mouth disease after vaccination, to think about which tests to use and how to interpret the results, and hopefully to demonstrate the value of working with vaccine producers and reference laboratories who can often add a lot to the work that you do and make it much more meaningful and conclusive. So the scenario I'm going to talk about in the video is the testing of some sera to evaluate immune responses to FMD vaccination. And so what we can imagine is that you have some cattle sera that have been collected in the field after a vaccination campaign. And you want to try and analyze these sera with the aim to find out really two questions that you can address, and in a way they are quite different, so I'm going to treat them individually. The first question is, has the vaccination been done properly? So are you sure that the animals have all received the vaccine, that the cold chain was right, that they've had the right dose, and that the animals have responded? And then secondly, another question that you can ask, which is related of course but slightly different, is are the cattle actually protected against the local strains of virus that they might come up against after vaccination? And this is actually a much more difficult question to address than the first one, which is why it's often worth thinking about them separately. And people perhaps tend to discount the value of doing the first of these questions, but actually it is very useful. So what we're going to talk about is the tests that you might use and how to interpret them, and a little bit about who will do different sorts of testing and what other complementary information, activities or assistance would be helpful to you in interpreting the test values. Okay, so if we go with the first question that we said we would try to address from analyzing these sera, it is, has the vaccination been done properly? And the first option for this is to benchmark the results you get on testing the field sera against suitable control sera. So where are you going to get these control sera from? Well, these should be sera from cattle that you know have been vaccinated properly. So I put here they've been vaccinated under optimized conditions, where you're sure that the vaccine has been stored and maintained properly, that the correct dose has been given, that the animals were all in good condition when they received the vaccine, and so on. And these, of course, should have the same vaccine batch as you're interested in evaluating in the field. And there's a couple of ways you can get hold of these types of control sera. One is to get so-called batch release sera from the vaccine producers, because when a vaccine producer makes a new batch of vaccine, he is supposed to put those vaccines into a small group of animals and check that they get the right immune response, what he expects for that particular vaccine strain. And so you could, at the time of requesting vaccine from the manufacturer, ask for some of these batch release sera, and these are very useful for benchmarking the results of what you get in the field. And then, as we discuss in the course notes, if you can't get hold of these batch release sera, the alternative is to use sera that you would obtain from a small in-country trial of your own, where you set up a small trial to vaccinate some animals and collect the sera from those. And then the other thing you would want to try and ensure is that some of these control and field sera will have been collected at approximately the same time after vaccination, because the interval between vaccination and when the sera are collected will also affect the strength of the immune response that you can measure. So then, once you've got these control sera as well as your field sera, you can test the control sera with any SP test of the appropriate serotype, and you can work out from there what result in the test you expect to get. And then you can see if the field sera, when you test them with the same test, give you similar results. So for this, you can use a convenient and readily available commercial SP ELISA. You don't have to know all the details about what the strains are in the ELISA. And you can compare the reactivity of the field sera to that of the control sera. And if the values you get from your field sera are similar to ones that you've got from the control sera or better, then you can be satisfied that the vaccination has been done properly. So a second alternative, and perhaps simpler to achieve this same thing, is if some benchmarking has already been done by the vaccine producer, and he can actually give you the test results that you can expect to get from the batch release sera using a specific test which is used by the vaccine producer and which you can also have access to. And then he can tell you what the test values in that test are, and you can simply test your field sera with the same test and find out whether you get the same results. So this would be an even simpler approach. And again, this reinforces the value of having good communication and working together with your vaccine producer, who can help you a lot in doing these sorts of exercises. So then the second question we said we would consider is whether the cattle are actually protected against local strains. So what we've just been talking about was the vaccination done properly, and have the animals responded in the way that's expected? And then this second, more difficult question is to answer the question, are they actually protected? So again, there's a couple of options or situations that we can think about. In the first scenario, we can imagine that vaccine matching work has been done and has shown a good match between the vaccine virus and the field strains that you want protection against. And if that's the case, you can use the pass mark established by the vaccine producer for the vaccine, which is based on a homologous potency testing, which means that the animals will have been challenged with the same strain as is in the vaccine. And if the field strains are essentially similar to the vaccine strains, then this same cutoff level should be adequate to protect protection against the field strains. So if the test used by the producer, for instance, is a virus neutralization test, which is often the case, but you want to use an SP ELISA to evaluate your field serum, then again you would have to do some form of cross-calibration to check what value in the VNT cutoff would equate to your cutoff in the SP ELISA. And again, to do that, you need either some control sera from the producer, these batch release sera that we've already discussed, or you could send some of your own field sera to the producer to get them checked by VNT, and then you could compare his VNT results with your SP ELISA results. So that's how you could do this cross-calibration. So a second situation, however, which is more complicated, is if the match between the field strains and the vaccine strain is poor, or the match is not known. And then it becomes much more difficult to assess whether vaccination using this particular vaccine will give protection or not. And really, to do that, you need to test the cattle sera against virus neutralization tests using the local strains in the virus neutralization test. And of course, not all labs are in a position to do these VNTs themselves, so this is where you would need to enlist the help of a reference laboratory. So you could test your field sera by VNT using the pass mark according to average values associated with protection, unless specific cross-protection studies have been done, which is usually not the case. And a point to make about all this testing is that most of the serological thresholds for protection are not studied at time points other than 28 days post-vaccination, and therefore it's much more accurate to assess protection at the same time point, i.e. about a month after vaccination. So for most people, this is the simplest time to do post-vaccination monitoring, is to collect the sera at 28 days post-vaccination. So to conclude then, there are some different options available for how you could analyze these field sera, and it depends a little bit whether you want to do something very simple or whether you're more ambitious and want to do something more complicated. But if you get yourself organized to have good support from the vaccine producer and the reference laboratory, then it's possible to do a range of options, even if you only have quite basic serological capability in your own laboratory. It's easiest to interpret tests on sera collected at 21 to 28 days post-vaccination, because that's when most data is available from vaccine manufacturers about the performance of vaccines. It's very useful and relatively simple to check that vaccination has been done properly, and this is probably going to be the main aim of your main post-vaccination monitoring in the field, is to address this question. So you would hopefully have already done whatever's needed to make sure that you're using the best vaccine, and then really the PVM can focus, rather than trying to answer the difficult question of are the animals protected, you can more address this question as has the vaccination been done properly. If you do want to do some studies on field sera to look at if animals are actually protected against the field strains, this may be best done as a separate, smaller exercise on a subset of the animals. It's useful to work closely with your vaccine producer and an FMD reference laboratory, and if you do this, you can often add a great deal of extra value to the work that you do yourself. And of course, it's important to collect and submit field viruses if you want to be able to estimate the levels of protection against these viruses using tests such as the virus neutralization test and with the assistance of reference laboratories. So I think I will finish there. I hope that that helps you to reflect on some of the things that are covered in the course materials. And I would also make a recommendation that if there are things that are still, after watching this video, not completely clear, you are very welcome to post questions in the discussion forum, because if there's something that you don't quite understand, it's very likely that the same situation will apply to other colleagues. So thanks very much for your attention, and I will leave it here.